Ho, ho, ho. It is the start of Chapter 4, ladies and gentlemen, and we're going to start with some detours and midpoints. We'll warn you that the proofs in this one are going to get quite lengthy. However, later on in the chapter, we're going to give you some awesome stuff to help you shorten those proofs up, go a little bit quicker. But we're going to start with some detours and midpoints, all right? We've used midpoints before, but we're going to use them in a new way. So detour proof is basically, it's almost like two proofs for the price of one, if you will. All right? So you prove one pair of triangles congruent in order to get some information to help you prove another pair of triangles congruent. How wonderful. If you didn't like proving one pair of triangles congruent, you certainly aren't going to like proving two pairs of triangles congruent. So I hope you do like it. Alrighty. So in this first example, we have circle O. That's what that is right there. You know, sometimes we have these typos. So let's see, we got circle. Whoop, that is a terrible circle. Circle O. All right. That's what that was right there. And we have angle B is congruent to angle C, and we want to prove that AO bisects BC. Okay. So let's think about this for a sec. I mean, we've got our congruent angles. That's wonderful. Now we've got a circle. And I want to prove that AO bisects BC. Well, if I want to do that, if I'm going to get those congruent, I'm going to need to get this segment congruent to this segment. Okay. So that's how I'm going to have to start this thing. Let's see what we can do. Because if I can get this triangle congruent to this triangle, I can get these two sides to be congruent, and away we go. However, remember, this is the detour one. I have a feeling it might not work out so nicely. But let's go with what we got. Well, I know that if angles, then sides could help me with these bad boys. I know that AE is congruent to itself, but if I do that, I'm dealing with an angle side aspect here, because if it's this side right here, it's going to be angle side. Angle side. So that's not going to work. We don't want that. To have any other information, I mean, not really. I don't know anything about these two angles up here, so that could be an angle side angle, but I don't have that. I don't know anything, obviously, about these sides. That's what I'm trying to prove. But I've got a circle here, right? With circles, it can be helpful to draw in radii. That was terrible. We'll deal with that one. That one's even better. All right. So if I draw those radii in, what do I know about all radii? They are congruent. I like it. So there's actually a few ways of doing this proof, but I'm going to go this route. I've got those two sides, the BO and CO, which I drew. Those are congruent by all radii are congruent. I've got BA and CA congruent because if angles, then sides. And then I've got AO reflexive, right? AO is going to be congruent to itself by reflexive property. I like it. Those two triangles are congruent by side. But how is that going to help me? Well, if I've got those two triangles congruent by side, then I can use those two triangles in conjunction with CP, CTC, right? I can use any of the corresponding parts of those triangles to help me get to my proof statement. Well, remember we said if we could prove BAE and CAE, those two triangles, if we could prove those two triangles congruent, we can get BE congruent to CE by CPCTC. So, once I've gotten my two big triangles congruent, what if I were to prove this angle and this angle congruent? If I got those two angles congruent, I can get BAE and CAE congruent by angle side angle. Ooh, that is lovely. Angle side angle go and do that for me. And once I've got that, I can get my BE and CE congruent and prove that it bisects. Okay, that was so much stuff right there all at once. So we're gonna recap that while we write up this proof, and I'm gonna need some room. Okay. So let's see here. Obviously, we've got our given. Let's start with BA congruent to CA. That is if angles, then sides. All right. And then I believe we said draw BO and draw CO. And we'll say aux line. Or 2 points determine a line, or whatever. Something about a line. Oops. 4. AO is congruent, or sorry, BO and CO are congruent. I do want to say that because if I'm going to draw them, I'm thinking I'm going to want to say they're congruent, and they are. O. All radii congruent. And then I've got AO congruent to itself. AO congruent to AO, and that would be reflexive, right? Okay, so I've got my triangles congruent. BAO, CAO. Yeah. Boom. So BAO is congruent to CAO. I like it. And that was by side, side, side. Cool, cool. All right. BAO, CAO. Now, why did I do that? Oh, that's right. I want to get angle. So I'm going to change colors here because I'm crazy like that. I want to get angle, BAO, congruent to angle CAO by CPCTC. And why is that? Well, if I had BAO and CAO congruent, I've got, so this angle and this angle are congruent. I've got this side and this side congruent, right? And I've got this angle and this angle congruent for my given. So that's angle, side, angle, right? Angle, side, angle. That gets my two triangles congruent. Awesome. I'm already with my next pair of triangles. So it's kind of like a second half of the proof. That's why I was changing colors here. So I've got triangle BAE congruent to triangle CAE. And that is by angle, side, angle. Need a little more room. All right. Now, step 9. Let's see here. BE is congruent to CE. And that would be by CPCTC. So I've used a triangle to get a pair of angles to help me prove the triangles that I actually wanted to prove congruent so that I can prove those segments congruent. And once I have that, I've got AO bisects BC, oops, 10, not 9. And that would be by definition bisect. Woo! That proof was quite the doozy, children. There we go. Again, a recap. I was looking at this proof. I'm saying, hey, you know what? I can't actually get the two triangles congruent that I want to get congruent. Because I wanted to get BE and CE congruent to each other by CPCTC. I didn't have the information to prove those triangles congruent. But I created two new triangles with two radii drawn in, which I was able to say they were congruent to each other by all radii congruent, and get those two bigger triangles congruent by side, 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 which allowed me to get those two blue angles with the tick mark congruent to each other by CPCTC, which then got me to my triangles that I actually wanted to prove congruent. These guys, this step right here. And once I had that, I can get my two sides congruent that I wanted, which allowed me to get the bisecting. Awesome. America. Alrighty, you'll be happy to know that we are done with proofs for today in this lesson. Yay! You know, I'm really just crying about it because I love proofs. I love them so much. They're so applicable to real life, you know, totally. Anyways, let's see here. We want to find the coordinates of O. We got a circle O right there. We want to find the coordinates of O. Well, I've got my two endpoints, 10, 8, and 4, -2. What do you think? How am I going to figure out my coordinates of O? Well, it's the midpoint. It's the middle. It's the center of the circle, so it's going to be between the two endpoints of the diameter. All right, so midpoint. We know that bad boy, right? That's x2 plus x1 over 2, comma, y2 plus y1 over 2. That's my midpoint formula. If you don't know that, jot it down. It's the average of your x's and the average of your y's. So 10 plus 4 is 14 over 2, comma, 8 plus -2 is 6 over 2, 7, comma, 3. That's O. Woo-woo! Okay, so this guy's 7, comma, 3, and I know that A is 12, comma, 0, right? And we're saying that AB is a diameter as well. What are the coordinates of B? Well, there's a couple ways of thinking about this bad boy. But I'm going to show you, I think, probably one of my favorite ways to do it. And we're going to deal with each piece on its own. So each coordinate, meaning the x coordinates, and then we'll deal with the y coordinates. So to go from 12 to 7 in that x direction, how far are we moving? We're moving 5 to the left, right? So we're subtracting 5 to get there. So if I subtracted 5 to get to the midpoint, I should subtract another 5 to get to my endpoint, which would be 2, right? 12 minus 5 is 7. 7 minus 5 is 2. I can do the same thing for the y coordinate. 0 plus 3 is 3. 3 plus 3 is 6. So 2, 6 would be my answer here. That was awesome. In fact, I feel like it was sometimes even a little bit easier than the midpoint formula. Not that either one's that difficult. Alrighty, so again, recap. How did I get from 12 to 7? I subtracted 5. Do it again to get to my endpoint. That's how I got 2. And the same thing with the y's. 0 to 3 is adding 3. Add 3 again, I get 6. Woo! Let's see what we're checking out here. We got find C if the midpoint of CD is 3, 5, and the coordinates of D is 9, comma, -1. I'm going to just draw out this segment. I don't even care to put it on like a coordinate plane or anything like that. I'm not really too worried about what it looks like on a graph for my purposes. So it says the midpoint is 3, 5. 3, comma, 5. That's my midpoint. We'll call it M. D is 9, -1. I got to figure out C. Well, let's see here. I think we could probably apply the same concept from the last problem. How do I get from 9 to 3? I subtract 6. So I'm going to do that again, and I end up getting -3. How do I get from -1 to 5? I would add 6. So I'm going to do that again, and I'm going to get 11. Boom. Done. That's it. From 9 to 3, I subtract 6 and do it again, get -3. From -1 to 5, I added, do it again, get 11. Woo. Just got to make sure you set it up correctly and not actually accidentally go from the midpoint to the endpoint, because then you're making the endpoint the midpoint. It's all jacked up. So be very careful. You're going from endpoint to the midpoint, midpoint to the new endpoint. All right, just in case you didn't get that last one, we'll do one last quick example. Feel free to pause it, try it on your own, and hit play when you are ready. I like to draw my segment. A, B. Midpoint is 3, -4. Endpoint A is 8, 3. All right, so how do I go from 8 to 3? I'm going to subtract 5, do it again. I get -2. How do I go from 3 to -4? I subtracted 7, do it again, -11. America, freedom, rock and roll. Woo! You can even double check it. Hey, if I add 8 and -2 together, that's 6 divided by 2, that's 3. 3 and -11, add them together, I get -8 divided by 2, that's -4. I just found the midpoint of AB. I double check my work. Check yourself before you wreck yourself. Fool. Here's the H-dubs. 2, 4, 5, 6, 8, 13. Freedom.